live perfectly. Okay, so we're back with our 13th episode of the Utility Strategy Podcast, the first infrastructure podcast to shine a light on what we love to call utility strategy. As we all know, buried utilities pose an enormous risk to any infrastructure project and create extreme uncertainty amongst the different stakeholders. Thing is that with the right utility strategy, we're able to mitigate that risk and streamline our project, which is what our podcast is all about. So sharing and gaining all kinds of insights that will enable just that. Helping project managers, utility coordinators, estimators, mappers, planners, designers, engineers, and any other stakeholder overcome the challenges of buried utilities in our right of way. To help us do just that, we have here with us today Jim Anspach, which some would call the founder of Subsurface Utility Engineering.
I think actually it's the Godfather of SUE. There,
Godfather.
I heard some, yeah.
Yeah. So I normally at this point take a deep dive into the background of our guests, but I don't think it's really relevant here, and I think I'm just going to pass it on to you, Jim, because I think our listeners are really interested to get the backstory of how our industry, the SUE industry, came to life. So, Jim, it's all yours. Tell us, how are you doing today? How's it going? Let's start with that.
Doing well. Doing well. You know, I don't know where that moniker Godfather came from. Somebody started it 20, 30 years ago and it kind of stuck. Now it's more like great grandfather, I guess. But in reality, the father of subsurface utility engineering was a fellow named Henry Garin Stutzman. And he was the chief relocation engineer for Washington Gas Light Company, which is the big natural gas company working in the Washington, D.C. area. And he was spending a lot of time, weekends, holidays, whenever, getting calls from different contractors saying, hey, we're out here on the job and your gas line is in the way. Get it out of the way. Or they might ask, your gas line is out here, how deep is it? And he started thinking, how can I address this problem? Because the only answer he was allowed to give from the lawyers at Washington Gas Light was, well, it's about SoDeep. And so he thought, well, you know, we're using these brand new vacuum excavation machines, which make a really small 8-inch by 8-inch hole in the pavement to expose our gas lines solely for the purpose of putting anodes on them to keep them from corroding on these old lines. There was no other reason to use that. And he said, you know, if I can find my utility, my gas line through that, I could tell people how deep something is. I don't have to tell them that it's so deep anymore. So he started the thought process of creating a company called SoDeep that would, through these vacuum excavation holes, which didn't impede traffic as much as a backhoe and wasn't as dangerous to the utility, would expose the utility. He could document where the utility was, give that to the contractor, everybody would be happy. So that's really how the concept started. Now, where it took off from there was, you know, to find that utility in an 8-inch by 8-inch hole, you have to be pretty good and precise at where you're going to dig that hole, or you can't find the utility. And so at the time, I was working for a company called Heath Consultants. I was their geophysicist and was working performing classes around the country in how to use these tools, these geophysical tools, pipe and cable locators primarily at that point, to find utilities. And the first day of business, when he couldn't find a utility in that hole, he called me up and he came. I told him about a class I was having. He came to the class and liked what he heard, and we decided to go into business together. So that was the first instance of using, I'm going to say, a scientific method to find where the utilities were rather than what it used to be called, which was pipe witching, witchcraft, right? It was all considered spooky stuff. We don't know how it works. We just turn it on and we use these welding rods and walk
When was this,
around.
Jim?
And
How
if it was
okay.
1981.
Yeah.
Well, that sounds like our
So,
trade craft.
yeah. So, needless to say, for a short period of time, we were using the geophysics solely for the purpose of figuring out where to dig a test hole with air vacuum systems to find utilities for the benefit of a contractor. But it very quickly became something else. And what happened was in the early 1980s, 1981, Fairfax County, Virginia decided to enter into an agreement with a satellite TV provider, a cable TV company. Cable TV was brand new back then. And it was a company called Media General. And Media General, as part of their contract with Fairfax County, had to guarantee that they could get cable TV to every single household in the county. Now, in order to do that, you'd have to buy massive amounts of easements and right of way to be able to get to every house. And they scratched their head and they said, well, you know what? The electric company already does that. It's the only utility, quite frankly, that goes to every house in the county. And so, therefore, if we could strike an agreement with the electric company to utilize their right of way and go right beside them or within their easement or on their poles, then we could meet that demand of the county. Well, the power company said, you know what? There's this brand new thing. We just started it here in Virginia. It's called the OneCall System. Most states didn't even have them yet in 1981, but Virginia was starting, and the power company said, you know, it's going to cost us a lot of money to mark our electric line, which you're going to be right beside. We don't want to have to spend that money. So, in exchange for using our right of way and our easement, you must not only protect and mark all of our electric facilities, first of all, so you know where the easements are and how close to us you're getting. But second, we don't want our other utility companies in the area to be damaged. So, Media General, you're going to have to mark not only our electric, but every single utility that is in our easement to make sure that you don't damage it. And that was the beginning then of a massive figuring out from Media General. How are we going to do this? You know, we don't even know how to find these utilities. So they entered into a contract with SoDeep. In late 1981, we started negotiations and we probably concluded those in 1983. And Media General was off and running. They had their franchise agreement. We had a contract, and we had to meet that demand of marking and finding every single utility in the Virginia Power right of way ahead of their crews. In addition, we used those Bear vacuum machines at every road crossing,
Wow.
because what they used was a hydraulic hammer device to jack a hole under the road to keep the paving good, and they didn't want to hit the utilities as they went across the road. So it was really the beginning of this concept, which we didn't call subsurface utility engineering yet. We called it designating, which was using geophysics to put a mark on the ground that designated where we thought the utilities were, and locating, which was exposing those utilities with the vacuum machine and saying, this is exactly where it is in X, Y, and Z. So we called it designating and locating. And when we did a sketch or a plan sheet, we also had to manage that data. So we called it designating, locating, and data management.
It's funny, Jim. I'm just going to say one thing. The actual industry has evolved now that they're calling the OneCall locating versus what you actually called it, what its intent was. So that's really interesting.
Well, the utility owners always called putting a mark on the ground locating. And when I started this concept of putting a mark on the ground for the purposes of figuring out where something was, we spent quite a bit of time, my college roommate Jeff Oakley and I, trying to figure out, what's this word locating really mean? The problem was we used locating when we dug it up, and we used the term locating when we didn't dig it up and just put a mark on the ground. So you had a term that meant different things. And we said, this can't be correct. We've got to figure out what the real term was. And so when you looked in the unabridged dictionary, it became clear that the mark on the ground isn't the location of the utility. It is a designation of where we think the utility is underneath that mark on the ground. And so we, in our business, which we are creating something brand new, we decided to call that function designating versus locating, so that it was clear what we were doing. We never were able to change the opinions of the utility owners from getting away of thinking, hey, I can put a piece of paint on the ground and I've located my utility. I said, no, all you've done is put a piece of paint on the ground. You've designated where you think your utility is, but it may be 100 feet away. How can you say that's located? So in any case, that's a little bit of that aspect. That got SoDeep started, this big contract of trying to find all utilities within the right-of-way with whatever tools we had, and then exposing utilities where there was going to be a crossing of those utilities. But it quickly became clear to us that there are other types of projects. And in this case, around the DC area, the Virginia Department of Transportation, VDOT, had massive projects going on. And those projects always had large change orders due to utility problems during construction. And the way they worked their magic in the old days was they asked the utility owners to draw their utility systems onto a set of plans when they were 90% designed. So at 90% design, the utility owners finally got their a set of plans, and they drew their utilities on and said, here's where the utilities
Wow.
are, Mr. Contractor. You go deal with it now. And of course, there were lots of unnecessary utility relocations and a lot of incorrect markings on the plans that caused problems during construction. And we decided to offer VDOT a bargain. They had a huge project going on at Washington National Airport and the Pentagon, where they were going to be increasing lane capacity through Crystal City. And we said, for a whopping fee of $10,000, we will go in there and designate all of the utilities on this project and then go in and locate with test holes where there are potential conflicts with design. Now, the real advantage was this project was already designed and ready to go to construction with what they had done their best job of saying, this is where all the utilities are, Mr. Contractor. Therefore, give us a bid. So we were actually at the right time able to go in and say, but here's where the utilities really are from our system. On the record, the Federal Highway Administration said we saved that project at least $1 million in change orders. Off the record, they said you saved at least $7 million that we can quantify, but they didn't feel comfortable saying it because it was such a big number, and it would really be a bad juju to say we've been doing this wrong all these years. So Virginia was well enamored of this process, and the Federal Highway Administration became really enamored of this as a way to save federal taxpayer money. So the Federal Highway Administration put a fellow, Paul Scott, who was the head of utilities for FHWA, kind of as point man for the FHWA, and Paul and I worked together to take this concept to other state DOTs with the backing of the Federal Highway Administration. And that all happened in 1984, 1985, while this large cable TV build was also going on. So SoDeep really came into its own in the early 19 and mid 1980s, where we were now doing designating for all utilities on highway projects in the state of Virginia and designating all utilities within the Virginia Power right-of-way for media general and digging test holes at conflicts. So that really brought us to the mid 1980s. About that time, something else momentous happened, and that was the gas company union went on strike. So that meant all of those new OneCall tickets that weren't related to the fiber optic, or not the fiber optic, but the cable TV build had to be performed, but they didn't have anybody to do it. And so they came to us because they knew we were the only firm in the country at that point marking utilities like this that weren't an actual utility company. And they said, can you add in all of these other OneCall tickets to your workload on a daily basis? And we said, wow, that would be a big effort. In fact, we had to hire 20 people and get them trained within a week to do those tickets.
So, Jim, it's really interesting. So, not only did the SUE industry start from that point, but also an entire LSP, the locate service providers, and that's really incredible.
That's correct. The contract locating for OneCall started with SoDeep at the same time, and we looked at it all as kind of the same thing, with the exception of for the OneCall tickets, we had to get things done within 48 hours, or we were not following the law. And we had to do it for a certain price. And we had to do it with people who were not fully trained, because we didn't have the time to get them trained. And so we did a great job, but what we realized over a period of about a year of doing these tickets was there's going to be damages. And we did not want the name SoDeep associated ever with any kind of utility damage or mismark, which we were able to do with our normal business because we had very highly trained, we had a big toolbox of geophysics, and our pricing structure was such that we were given the money to do it and the time to do it right. And we figured with this OneCall business, we'll never have the time to do it right. We'll never be able to have the money to do it right. And so, therefore, even though we might be able to make money at it, there would be damages associated with it. And we didn't want to drag the name SoDeep through that damaged mud. However, before we got to that point and said we no longer want to do these OneCall tickets, it was pretty clear to me that the main problem with OneCall was every utility owner sent their own person out to mark their utility, and the travel time of going from one ticket to the next ticket to the next ticket was the main driver in cost. And so we actually developed a mathematical algorithm that showed that if a single person out there was marking all the utilities, the driving time would be cut by the number of tickets that were, or utility owners that had to respond to that particular ticket. And the whole system would be much more efficient from a time standpoint, but it would also be more quality oriented in that once that one person gets there, they're trying to find all the utilities, not just one utility. And therefore, you might get confused with what's this really good conductor that's the abandoned water line, but I'm trying to find the gas line over here that isn't as good a conductor because it's old cast iron. So we put this algorithm together and proved that it would be better for everybody if there was what we called a multi-ticket response by a contract locator in the 811 system. And Bell Telephone, there was a fellow in Northern Virginia, his name was Happy Hash. He was the lead engineer for Bell Telephone. He got it. He understood. He was a professional engineer. He understood that mathematics and said, oh my goodness, Bell Telephone needs to start doing this. This is the way to do it much more efficiently. And hence the contract locating multi-ticket industry was born, but we diverged the two types of business. One was for the benefit of the project, where you had the money and the time and the right people and the right equipment to do the job right. And the other was, at that point, a low bid service trying to satisfy the obligations of the utility owners for damage prevention. So all of that was happening in the 1980s, mid 1980s. Then another thing happened, and that was that we realized in Virginia that having good data wasn't enough. You had to know what to do with that good data and get it in the hands of the engineers to avoid utility relocations when possible. So we actually started working performing utility coordination services for Virginia DOT. So we were designating and locating the projects. We were surveying the utility data and getting it on the plans. And then we were taking that data and communicating to the engineers and the contractors and the utility owners where those utilities were and how they needed to accommodate them, relocate them, or avoid them for the maximization of benefits
Jim,
to the
if I
public.
And
And
Reddy,
that's
all this even ahead of time before any standards were written. So you guys were going off, off the cuff, ad hoc, developing industries. When, I want to understand how did you bring this all together to actually start forming these standards, or that's a little bit down the road?
it's a little bit down the road, but it's not that far down the road. So we were doing these pieces of work that we felt would help solve a problem, and of course FHWA was our lockstep partner, along with some of the more innovative state DOTs. At that time, it was Virginia for sure, Maryland, New Jersey, Pennsylvania, Delaware. Those were the main firms, or DOTs, that really embraced this concept, and it makes sense. They were all in the Mid-Atlantic, where the utility systems were old. There were older cities. There was a lot of population growth there. It's where they needed it the most. And considering we were all in the Washington, D.C. area, we could talk Mid-Atlantic dialect. We knew the talk. We didn't have a Southern accent. So at that point, you couldn't work in Georgia because you weren't a Georgian. So in any case, we started working in other areas of the country and for other things, other types of projects beyond highway projects. One of those projects was a Department of Energy project at the Savannah River site. That was a very interesting project in that they had a lot of old copper communication cables, and Bell Atlantic wanted to upgrade to all fiber optic. They wanted to put a whole new command and control facility concept into their Department of Energy site in Georgia. And they asked SoDeep to put together a proposal to designate the utilities. But as part of that proposal, they said, and you have to have a robust quality assurance program. We said, oh, well, what might that look like that would satisfy you? And they said, well, we don't really know. That's your problem. But here's our quality assurance program in a way that maybe you can figure out how to mimic it. There are, in fact, 4 levels of nuclear alert at these Department of Energy facilities. One is, hey, there might be a problem. And on the other end of the spectrum, it's, holy crap, you're going to die. Just, may as well lay down. You can't even run away. And then there were 2 other alerts in between. One was, get out of Dodge as quick as you can in your car. And the other was, try to find shelter as far away as you can, but things are not looking good. So there were these 4 levels, A, B, C, and D, of nuclear alert. And as we had been doing our utility designating and locating, we always realized that there were utilities that we were unable to get any kind of geophysical signal in the field. Maybe they were plastic, maybe they were real deep. Whatever the reason was, we couldn't find them. And yet there might have been a record and or maybe even visual evidence that a utility might be there. And so we used to call that on our sets of plans DATUR, depicted according to utility record. And that depicted according to utility record kind of was in between. We could either get it from geophysics or we could expose it. But here is another classification that we just have to raise our hands and say, we're going to let you know we think it's there because somebody has some information, but we can't verify it. And so we'd add these labels DATUR. But once we looked at this Department of Energy site and realized, well, we need 4 levels in here. We said, that DATUR that depicted according to utility record really could be broken into 2 different pieces. One is there's only evidence from a record versus there is also a surveyed point, a valve box, a pole, a hydrant, that we can actually get a really good survey point on it and correlate the records to it. And that's really where the quality levels for utility came from. Quality level D was it's only records. Quality level C was there's a few points out there we could survey and add the record to it. Quality level B was we could designate it with geophysics, and quality level A was a place where we actually exposed it and knew where it was. So that's where the quality levels came from. Came out of the Department of Energy quality assurance plan
Jim,
at Savannah River.
I think
Now,
that no,
go ahead.
it's amazing to hear you describe this, but I think today that we take the quality levels for granted, like because it's inseparable from our industry. But what was kind of the back talk or the opinions or the what were the cynics saying when you were kind of presenting this to them? Like
Well,
because it wasn't really subsurface utility engineering. It wasn't as big as it was today.
yeah. So to answer that, I need to actually talk a little bit more about the history. The original concept of what we were doing, designating, locating, and data management, was we wanted to go out and find all utilities within a project limit, whether there were records for them or not. And so we used geophysics extensively with a lot of different kinds and a lot of different search orientations to find unknowns. And we were really good at that. We generally get 30-40% of utilities beyond what the record said out there on the site. And the concept of showing something at quality level C or D really was only because there was evidence that it was there, but we couldn't designate it. Now, what happened was FHWA is trying to sell this concept to the to the DOTs and say, we want you to try this. It saves you money and time. That's really where the cynics were. The cynics were in the DOTs saying, well, it's the utility owner's problem.
Unbelievable.
They're in my right of way. They put it there. They're supposed to have good records. Why should I pay for it? We're going to make it their problem. We don't care about anything. But the FHWA said, well, what can we do to bring them more in alignment with our side of or our way of thinking? And what they said was, well, there are all these project flow charts that DOTs have. And generally, when they go to figure out where the utilities are, they get the records or they get the utility owners to show where their facilities are on the plans. And then they do a topo survey, or maybe they do a topo survey and then they get the records. But they only do what essentially was that depicted according to utility record, DATUR function. They never designated anything. And maybe during construction, they would call the OneCall system and get a few marks out there. And they would call up the utility owner and say, you better find this. It's in the way, dig it up. So they might get a test hole, but at that point, why document anything? Because it's in the way, you're just going to move it or work around it. So what the FHWA did, which looking back in hindsight was not beneficial to the concept today of subsurface utility engineering and quality levels, was they said, let's try to mirror your practices and your flow chart. First, do quality level D, get the records, plot that, then do a survey of what you can see topo wise, and then move the utilities that were at quality level D to that. And then during one call, you're going to designate it, or maybe you'll do it right before one call, and then you can dig some test holes. And so they made it a linear process. You got to do D, and then you do C, and then you do B, and then you do A, which was totally counter to the real efficient way that SoDeep had developed, which was try to get quality level B on everything. And what you can't get at quality level B ends up being whatever was available, C and or D, and then do your test holes. So that was a combination of the cynics, in that it's the utility owner's problem coming from the DOT, but in order to make it more palatable, we tried to force a compatibility with their thought processes, which are all screwed up in the first place. As far as being an efficient way and understanding that utility owners really don't know where their stuff is. So that brings us up to 1989 and maybe 88. And at that point, the Federal Highway Administration, in conjunction with Reva Reed, who was a Bell Atlantic regional manager, said, you know what? We need to have a National Highway Utility Conference where we can bring the utility owners, the contractors, the engineers, and the DOTs, the FHWA all together on an annual basis somewhere in the country and talk about these issues that we're having. Remember, there wasn't really a one call industry that was gelled yet.
There was
They
no
were all
support.
kind of individual.
Yeah.
There was no national, no CPA, nothing like that. So, and AASHTO, although AASHTO, the American Association of State Highway and Transportation Officials, had an annual meeting, utilities weren't well
They weren't
thought
part
of
of the
back then.
conversation.
They weren't an AASHTO problem. And no consultants were allowed at those meetings. Only state highway officials were allowed at those meetings. So there was no forum for everybody to get together and talk about these issues. So we created this forum, and that went very well for a number of years, so long as FHWA funded it. Once FHWA stopped funding it, the state stopped coming, and the whole thing fell apart. But that during that first National Highway Utility Conference, we decided that we needed to call what we were doing, designating, locating, and data management, we needed a new term. We needed a term that implied and gave the concept that we were performing an engineering design service. We're creating data for the use of the engineer, not for the use of the constructor at the end of the project. So we beat it around the management team at SoDeep, and we came up with this idea that, it's what we're doing. Let's call it subsurface utility engineering. And we presented that name at that first annual National Highway Utility Conference, and now we had a name for what we did. So the FHWA got behind that, and so now we had really almost all the elements for what we were doing. We were investigating and documenting where utilities were on projects early. We were taking that data and using it for utility coordination purposes. We were actually doing utility relocation design if something was in the way. when we exposed a utility, we could document what its condition was, which may influence whether we relocate something or just fix it. So all of these ideas started to get lumped together in my mind, that subsurface utility engineering is really, designating, locating, data management, utility coordination, condition assessment, utility design, utility relocation design, all of that. And we started promoting it as such. Now,
I'm going to ask a question in terms of that. For some reason, I don't know why, I always thought that SAMI had a big influence in terms of the classification, very similar to the other militaries around the world that used within their combat engineering corps classification of information, A, B, C, and D for reliability of use.
No, they had absolutely no influence at that time. So, what did happen was SoDeep was the leading firm doing this work. We had developed all of the concepts, but FHWA was promoting it, and different DOTs were saying, you have to have competition. We can't just give this work to you. You have to have competition. And so competitors sprang up, mostly ex-SoDeep employees who decided, hey, let me team with an engineering firm or a survey firm, and we'll go out and we'll do this same thing, and we're guaranteed to get some work because SoDeep needs some competition. And that happened. But nobody else was doing the complete package. Most of them they bought a vacuum truck and they knew how to dig a hole. They didn't like the designating because it was difficult and you had to really know your geophysics, and they didn't. And you had to have a surveyor to survey it, and they didn't. So there were a whole bunch of what I'm going to call low-end firms trying to do what SoDeep was doing. So SoDeep had the total package, looking at it as a professional engineering, surveying, geophysical licensed firm, while there a whole bunch of our competition, all the competition really, were contractors working with an engineering firm saying, how can we make money at this thing and take work away from SoDeep? So they really liked digging holes. They could maybe do some of the designating, but not very well. And this went on, and we saw the quality start to decrease out there. But what happened was, as we would go into new areas, SoDeep would continue to win the majority of the work and be the favored client for the DOTs because we gave them what they needed. And the other firms would miss the unknowns, and they would have dry holes with their vacuum machine, and they would still charge the client, and they didn't get as much work. And so these other firms said, what we need is an association so that we can essentially stop SoDeep from getting a bulk of the work and spread it out amongst all these other pothole firms. And they started using the word pothole rather than test hole. And that idea that we needed an association in order to dumb down our services really made me a little bit angry. And one day, Paul Scott and I were teaching a class in Alabama, at the University of Alabama, in this new concept of SUE. And afterwards, we went to the dean's house and had dinner. And
Sorry, David, did you miss that as well? I think we missed, I think it glitched for like 10 seconds. You were just about to teach in Alabama.
Yeah. So we were teaching a class at Alabama, and the dean of the School of Engineering invited Paul and I over to his house for dinner. And I was explaining to him this dilemma I had where I had this competent engineering service, but a bunch of my competitors wanted it really to be a dumbed down contractor service that they could just make money from and not do engineering. And I mentioned this to him, and he said, well, you know what? I happen to be the incoming president for this group called the American Society of Civil Engineers. And
Amazing.
we have engineering standards. And he said, you've already done all the work. You've got this concept of quality levels. You've been doing it since the 80s. It's obviously highly successful and in the engineer's best interest. And we have this problem in the engineering world in that although we put disclaimers on plans saying engineers are not responsible for the utilities, it's the responsibility of the contractor at time of construction to deal with the utilities. He said the courts are starting to say, it's a differing site condition, and we're not going to let you out of this liability, engineer. So this concept of quality levels could be a way to help solve the problem of increasing engineers' liability. So he said, why don't you do this? Put together a proposal to write an engineering standard and see if ASCE would accept it. So I did that, and they accepted it. We put together a committee, and this was in 1996. And 6 years later, we had pretty much developed and formalized the concepts of quality levels and created the ASCE 38 standard. So that is really a short a synopsis of how we got from the concept of utilities are in our way on Christmas Day in 1981 to the year 2002, where we now had an engineering standard and a whole new profession called subsurface utility engineering in place.
Jim, I want to ask you, what was the most fulfilling point within that first decade or that first evolution, where you felt, yes, we've done something?
That's a really hard one to say, because I would have to say I was in ecstasy from 1981 through the 2000s. I mean, it was full speed. You don't have time for anything else. Get up at 4 in the morning, work a 14, 15, 16-hour day, do it 7 days a week. And you're coming up and you're doing something that nobody had ever done. You're adding in, you're going around the world. I was going around the world trying to find new geophysics, new ways of doing things, adding new kinds of clients like the White House and the CIA and the State Department and the Pentagon and all of these DOTs and Department of Energy sites, and going around the world. It was all so fulfilling, Ophir, that I can't really say, looking back, that there was any one particular point that really sticks out in my mind as giving me more joy than another. I will say that, getting the Media General contract, and then getting the Virginia DOT contract, and then getting the concept of quality levels, and then starting to work for some of our secret agencies, 3-letter agencies in the country, and kind of being part of of feeling bigger than just the engineering world and yourself. And then finally getting that good association with the American Society of Civil Engineers and getting an engineering standard. All of that was really fulfilling. I really can't look back and say one part was better
What was
or more
the
fulfilling than
feedback
another.
for ASCE 38 once it went through?
Interesting concept. The feedback was generally good. FHWA really was pushing it. The execution was really poor by providers. They would not read it. They would just take a definition and they would change the definition to meet their particular purpose, or they wouldn't understand. Very few people actually followed the steps that were in there, and they would try to twist it to their way of thinking. And that still goes on today, which is why we are in the process and will, within a month or two, have a republished version that is much more descriptive and prescriptive of what you have to do to get to a quality level. So there was, overall the reception was good. A lot of state DOTs and still today have never read ASCE 38 or understand it. They just listen to what somebody else tells them they think it says and what they do. The problem is we've had court cases where ASCE 38 is in court, but because of the amount of money, all of these cases settle and they don't get into case law. They just get into, the lawyers spreading the money around and paying for the problem. So it takes a long time. It really takes a long time, and we're getting there. It's hard to believe, 40 years later, we're not doing this as a routine business on every project, although we are now in Colorado. So we are making progress in that regard, and we're
Maybe more
continue
states to come as well. We're seeing great stuff happening in Minnesota that are doing some really interesting stuff. And also, I think around the world, there's been some inspiration from what's happening in the United States. So we can see what's happening with NUAR in the UK and what's happening in Singapore.
Well, hang on a second, David. You're mixing up a couple of different things. NUAR is the registry of all utilities and not the designation of utilities.
But the awareness is
really,
out there.
It's a couple of different things, but yeah.
The awareness is there, and really, it started in the UK with their mapping the underworld project, and them looking at what we were doing here in the US with ASCE 38. They didn't want to change it to metric, and their way of doing business is different over there. So they created their own standard, but it's very similar to ASCE 38 with the quality levels. And then Australia followed along, and then Malaysia followed along, then Ecuador followed along, and then Italy followed along, and so really the genesis of all of that came out of ASCE 38. They're all so very similar based on those concepts of there are 4 ways to discover a utility. You can dig it up and see it and measure it. You can use geophysics to get an inference of where it might be, and if it exists, you can make an inference because you can see a few isolated spots at the surface that indicate that, and you've got some source of second party information from records or old project records or GIS systems. That's it. Those are the 4 main categories. And we were able to initially figure that out, and then the rest of the world is coming right along in lockstep with that.
It's an incredible process when when you're first starting something and you're really trying to build upon that, and you're trying to build the best quality product which you actually can put forward. I find it disheartening if people are starting to do half measures within that and saying, here, we have a product which is almost good enough, but start using this instead because it's cheaper.
Well, we had those conversations early on. Do our clients want a Chevy or do they want a Cadillac or a Lexus? And each client is different, and each project is different. And as what I would like to see though is everyone using ASCE 38 because it does give you the flexibility to do the project in the way that it should be done, but gives you flexibility in cost and scope and all of those other things. And if that's the one message that I could get out to the engineering profession and those practitioners who say they are doing subsurface utility engineering, it's that ASCE 38 is not restricted. It provides a framework for everyone to meet their needs as to whether they need a Chevy or a Cadillac.
So, Jim,
It's all available.
this has been an amazing episode talking about where subsurface utility engineering started. We're going to have another episode talking about where subsurface utility engineering is now. But for now, I think we're going to sign off and keep our listeners posted for the next episode that we're going to have. So, but this was absolutely amazing.